Hey everyone. So, you've probably heard the terms AI, machine learning, and deep learning thrown around a lot. It can feel like a confusing jumble of buzzwords, right? Well, trust me, you're not alone, but they're not nearly as complicated as they sound. Let's break down exactly what they are, and more importantly, how they all fit together.
You see them in news headlines, you hear about them in tech talks. They're powering so much of the world around us. But how do they actually relate to each other? Are they three separate things? Is one part of another? That's the big question. Well, you have absolutely come to the right place. We're going to clear all of that up right now, nice and simple, so you can see exactly how this puzzle fits together. Okay, let's start with the biggest, broadest concept of them all, artificial intelligence. The best way to think about AI is as this giant umbrella that covers everything else we're going to talk about today. So, what is it really? At its heart, AI is the whole science of trying to make machines smart. The ultimate goal here is to build systems that can mimic human intelligence. Things like learning from experience, reasoning through a problem, and just generally understanding the world. I mean, a truly intelligent system isn't just following a pre-written script. It needs to be able to learn as it goes, draw conclusions from what it knows, understand what it's seeing or hearing, and even interact with us in a natural way, kind of like we're doing right now.
And here's the thing, you already use it every single day. Just think about the virtual assistant on your phone or in your home. When you ask Siri or Alexa for the weather, you're interacting with a classic broad AI system.
So if AI is the grand vision, how do we actually make it happen? Well, one of the most powerful ways to achieve AI is through something called machine learning. And here's the absolute key distinction you need to remember. Machine learning is a subset of AI. Instead of a human programmer sitting down and writing thousands of if this, then that rules, we just let the machine figure out the patterns for itself by showing it a ton of data. The process is actually pretty straightforward. First, you gather a massive amount of examples, let's say thousands and thousands of pictures of cats. Then you train an algorithm by feeding it all that data, letting it slowly learn all the little patterns that make a cat a cat. Finally, it can use what it's learned to make a solid prediction on a brand new picture it has never seen before. A perfect everyday example is your email's spam filter. Nobody programmed it with a list of every possible spam word in the world. Nope. Instead, it learned what junk mail tends to look like by analyzing millions of emails, and it gets smarter every single time you mark something as junk. Okay, so under the big umbrella of AI, we have a key technique called machine learning. Now let's get even more specific and talk about the most advanced approach we have today, deep learning.
Deep learning is a really specialized type of machine learning. And the deep part of the name, that comes from its structure. It uses something called artificial neural networks, which have many, many layers stacked on top of each other. And this whole structure is loosely inspired by the massive network of neurons in our own brains.
This multi-layered structure is exactly what makes it so incredibly powerful. It can chew through enormous data sets and automatically figure out really complex, subtle patterns all on its own. This is the technology that's driving most of the major AI breakthroughs you hear about in the news.
You want some mind-blowing examples? Deep learning is the magic behind the facial recognition that can instantly tag you in a photo. It's also the vision system that allows a self-driving car to identify pedestrians, other cars, and traffic signs, all in real time.
All right, we've covered all three pieces of the puzzle. Now let's put it all together and see exactly how they connect. This chart shows the hierarchy perfectly. AI is the entire broad field. Machine learning is a core technique within AI that learns from data. And deep learning is an even more advanced, specialized technique within machine learning that uses those deep neural networks. They aren't three different things. They're nested inside each other, like Russian dolls. So, you see, this isn't just abstract theory for computer scientists. These technologies are already deeply woven into the fabric of our daily lives. Ever wonder how Netflix or Spotify just knows what you want to watch or listen to next? That's machine learning. Or how your bank can instantly detect a weird transaction on your credit card? That's AI. It's in the chatbots you talk to for customer service, and it's even in healthcare, helping doctors analyze medical images to spot diseases earlier than ever before. And this quote really just nails it. AI is no longer some futuristic sci-fi concept. It's a practical, everyday tool that we all interact with constantly, a lot of times without even giving it a second thought. But how in the world did we get here? I mean, this technology didn't just appear overnight. Let's take a lightning-fast tour through the history of AI.
So the whole idea was formally born way back in 1956. And for decades, it was kind of a slow burn, with huge milestones like IBM's Deep Blue beating the world chess champion in '97. But the whole game changed around 2012 with the deep learning revolution, which unlocked these incredible new capabilities. And that has led us directly to today, where generative AI like ChatGPT is literally changing the world right before our very eyes. So if you remember just one thing from all this, let's lock in the key takeaway. Think of it like this. AI is the big dream of intelligent machines. Machine learning is a practical way to get there by learning from data. And deep learning is the supercharged, brain-inspired version that's powering today's most incredible applications. Hopefully that clears things up. Now you know the difference. But it leaves us with a really interesting question, doesn't it? If these systems all learn from data, what does that learning process actually look like? And as this technology gets faster and smarter, what incredible things might come next?